going to record. Alrighty, so I will be putting I'll put the Jamboard up there. I'll put the solutions up there. Yes. Okay, so you guys are gonna have to send me an email and tell me that, send me an email and say I didn't hand it in after. So were you not finished?
Oh, no, I'm finished.
Well, I mean, like, why? Because I had said to Mr. Quinn they hand it in at the end of class when they're done. So were you not finished? Is that why you?
No, it was at my house that day because I didn't know.
Okay. Yes, Matthew. Pardon me? Well, I just mean like, this is like not the entire class. The majority of the class handed it in. So you'll have to send me an email telling me why I don't have it in my mark book. Okay? Yes? Pardon me? No, it's okay. It's fine. Alrighty. So on Friday, you'll have a quiz on density calculations. You will have a unit test on all of these characteristic properties and non-characteristic properties when we're done the unit. Remember when we started all this thing, we were looking at this problem where someone bought this anti-sweat spray, right? So this is something that should be in the back of your head all the time, but we're taking a little zoom in with density, because stuff like density calculations, these are things that follow you for, like, I swear, for the rest of science. You see density when you are studying in Sec 3 science, it's there, talking about different fluids in the body and whatnot. There's density calculations there. And in chemistry and all this stuff, density is very important. And we also, with just the different scenarios that we saw in terms of, you know, why do things sink? Why do things float? Density is important. So I'm going to spend a little bit more time on density than the other things that we started looking at. So you were supposed to do this problem set, this worksheet. It was relatively straightforward for the most part. I looked over, and for the most part, I think everyone did pretty well. But just because it was before March break and you have a quiz on this on Friday, we're going to correct this together. So I told you how I want you to do your problems. I always want you to be looking at the problem, reading it first, and then writing down the information you have. It's the same thing with every other test that I've told you. Everything else, I'm always like, what do you have? What are you looking for? I want to see that inventory on your test, right? And I want to see what formula you're using before you start plugging things in. Okay, so it needs to be pretty thorough. So the first problem was pretty much straightforward. A block of aluminum occupies a volume of 15 milliliters and has a mass of 40.5 grams. What is the density? So I read it. And then now what's the next thing I told you guys I want you to do, Rocco?
You put for mass, you put 40.5 kilograms.
Okay, so
40.5 grams. And you put the volume. And then you put B equals 15 milliliters.
Okay.
And the formula is density equals mass over volume.
Okay, so you've told me what you're given. You've written your formula, and I would also like to see your unknown. So they're asking you what is your density. So I'd also like to see you saying, oh, this is what I'm looking for. Okay, so that's great. Anybody want to tell me how to set this up? I know Matthew had your hand up before. Okay. So what? So grams per milliliters. Okay, so I want to see units. Okay, if you don't give me units, this is a major issue. As I mentioned to you before, if I were a nurse or a doctor and I'm giving a volume of something, of a certain kind of medication, and I just see 2, well, what is it, 2 liters? to milliliters, to deciliters. Like, you know what I mean? Like, how much am I giving? So it's important to have units. Yes. No, because centimeters cubed is another type of volume, right? For a solid object. And here, our volume is in milliliters. So that's why it's important to look at the units that you have in the problem and write it down, because then your final answer, you won't mess up the units because it was actually a part of your equation. Yeah. Pardon me? So if you were given a volume and they gave it to you in like distances, right? They gave you like, you know, the length, width, and height, then you only would be able to use the regular formula for volume, which is length times width times height. And then you would have like something like centimeters cubed or something like that. But generally speaking, we use the units like centimeters cubed if we have a solid, and stuff like liquids and all that stuff was milliliters and liters. But in some of the problems, you'll see that regardless of if it's a solid or liquid, they use different units. All right, so did you guys get this? Give yourself a nice big check mark. Yeah. Nice big check mark. All right, number 2. Mercury metal is poured into a graduated cylinder that holds exactly 22.5 milliliters. The mercury is used to fill the cylinder, has a mass of 30.6 grams. From this information, calculate the density of mercury. Anybody else? You 3, I know you know what you're doing. Oh yes, Lucas, he didn't talk yet today. All right, so what's the first thing that I'm doing?
So you know this information, so the mass is 306 grams. And then the volume is 22.5 milliliters. And we don't know the density yet.
Okay, and then they asked me for the density, right? So I'm just gonna put.
So I did D equals 306.
Okay, first I want to see what formula you're using.
Oh, yeah.
Okay.
I just put your mass divided by 306.0 grams over 22.5 milliliters.
Equals
And you
13.6.
get 13.6 grams per milliliter.
13.6 grams per milliliter. Did everyone get that?
Yes.
Are we lying? All right. Kelsey, sweetheart, 13.6 grams per milliliter. All right, so we went through the problem. We saw what we were given and what we're looking for. And that's how, so like when you have an exam and you have, so this is, we're studying density. So you know what formula it is. But when you get to further on in science and you have a whole bunch of different types of situations, you'll have a whole bunch of formulas, right? And this helps you when you start listing what you have and what you're looking for. This helps you go to your formula sheet and figure out what formula am I going to use. That's why I'm getting you in this habit, because if you're going to do chemistry, you're going to have a whole 2 pages of formulas. So again, listing what you have, listing what you're looking for, lets you sift through the formulas and say, oh, this is the formula that I'm going to use because this is what I have and this is what I'm looking for. Yes, Rocco? Absolutely. I would never, ever want you to do this kind of stuff in your head. And what? That's the second one? After this unit, I believe you're going into life-sustaining processes. I think you're going into like sexual education and all the stuff that's happening in the male and female body. Solano. Okay, number 3. What is the mass of ethyl alcohol? Shh. All right, guys. What is the mass of ethyl alcohol that exactly fills a 200 ml container? The density of ethyl alcohol is 0.789 grams per milliliter. Aiden Westra.
So your volume is is 200 milliliters.
Cool.
And then your density is 0.789 then your unknown is the mass. So you,
So they're asking me for my mass.
so you
it's-
multiply 200.
We're not there yet. And what do I do after I've written what I have and what I'm looking for?
dV.
D is equal to, what's the formula for density, guys?
But because we have we're trying to find the mass.
Yeah, but I want the original formula
Okay.
first.
So it's D equals M over V.
Okay, cool. And now I can plug in stuff. So what am I writing?
So it's 200 multiplied by.
Let's use the formula first. We're plugging into the formula. So that goes into there. That goes into there.
Don't use fish method, please.
And my mass, I don't know. My volume is what? Okay, so there's this imaginary 1 over there, and you guys call it fish method. It's just algebra. It's just solving for an unknown. I'm going to cross multiply. Matthew, what's the next step? What am I writing? 789 what? 10, no. Okay, so what happens to my milliliters? They what? Look at the milliliters. They cancel out. Okay, so what was 200 times 0.789? Sorry, tell me again.
89. Oh, wait, I thought my G was.
Check again.
Was that right? Did you guys get that? I didn't use my calculator, so I'm trusting you.
Yes, it is.
Yeah? Fulvio, did you have a question or you wanted to do the next one? Sure? Well, because I want you to keep in line with math, right? And so I'd like to see the canceling out. I'm not going to take off marks saying, oh, you didn't cancel out, but I want you to see that this scientific equation is just really mathematics, right? Yes. Sure, sure. I'm not sure yet. We'll see. You prefer paper?
Yes. Then we'll have to write mass equals.
Okay, I hear you. I hear you. Alrighty. Yes, Wiseman, you're going? Sure, ask it away. If you don't what? Sure, sure. Like, what did you do? Density times, which is ultimately, right?
No, it's density times volume.
So you did density times volume. Essentially, what we're doing is that in the end, right? It's just that we're skipping steps when you say it like that, but to ultimately get there, it's the same thing. Okay. Alrighty. Antonio. Okay, like let me. Oh, sorry. Can you do the next one? Okay, I haven't heard from Antonio today. So I'm gonna read it, and then Antonio's gonna tell me what to do. A rectangular block of copper metal has a mass of 1,896 grams. The dimensions of the block are 8.4 centimeters by 5.5 centimeters by 4.6 centimeters. From this data, what is the density? All right, so Antonio, take it away. Okay, Antonio, just a second, sweetheart. I'm not disputing with you, but first I'd like you to write down, tell me what I have, okay? And what am I looking for? So what do I have? Okay. Well, I don't have a volume yet, right, sweetie? No.
Yeah, so you have to multiply.
Okay, so I'm gonna just say length is 8.4 centimeters with, I'm just gonna just 5.5 centimeters.
But then say that, Sam. So are you just labeling that?
I'm just doing randomness. But I want you to show me that you have dimensions of something, okay? So if you have length and width all mixed up, it doesn't matter for this situation. I want to see that you're telling me I have lengths here, okay? Antonio, next, what do I do? What are they asking me to find? Okay, so I need to find my density. So what's the formula for density? Okay, D is equal to M over V. So I have a mass. I don't have my volume. Okay, so how do I find my volume? Okay, so 8.4 centimeters times 5.5 centimeters times 4.6 centimeters. Sorry, sweetie, what was my volume? 212.52 centimeters what? Okay, so that cube tells me I have a what?
That means you have a volume.
Oh, volume. Okay, now what do I do? Okay,
And it equals 8.9.
wait, can we let Antonio finish? He's on, sorry, 8 point,
No.
92155.
oh, sorry.
This is your answer.
Antonio, tell me what it is.
Wrong.
8.922.
Wrong.
8.9.
8.92151. If you're not here, he said he rounded it up.
Okay, so he rounded it off. He gave me 4. That's fine. Our mass had 4 figures. So grams per what? How do I know that that's a density? What would give it away looking at this? The units? And what about the units? Kevin, I heard you. What did you say something? No? Oh, okay. What gives it away that it's a,
The unit.
so I have a mass over a volume, right? Darling, what's up, hun? Sure, like I wouldn't remove marks for that, but I just, like I told you, we're listing what we have, and I didn't have a volume, right? So I listed length. Sure, that's fine. I'm just getting in the habit of listing what I've got. All right, Fulano is next on the science and technology show. Shh. Okay, wait, hold on. Let me read it. A flask that has a mass of 345.8 grams is filled with 225 mLs of carbon tetrachloride. The mass of the flask and the carbon tetrachloride is found to be 703.55 grams. From this information, calculate the density of carbon tetrachloride. So first, what do I have here? So tell me what's going on here. This one was a little bit more difficult. You had multiple steps to do. Sorry, go ahead. Okay, wait, hold on a second. What am I looking for? Okay, so I would need a mass and a volume. Okay. So the mass of the flask is equal to what? Okay, and what is this mass here? So here I said this CCl4 carbon tetrachloride. So it means it has 1 carbon and 4 chlorine molecules. So that's why I wrote it like that, CCl4. Okay, so how do I find out the mass of the CCl4? $357 point. Okay, hold on. Touch it. Someone had a question back here. Was it you, Touch it? Oh, you didn't have to know that. I just didn't want to write carbon tetrachloride. Right? So it's telling you you have a mass. You have a flask, and it has a mass of 345.8 grams. That's the mass of the flask alone. They tell you that the carbon tetrachloride and the flask has a mass of 703.55 grams. You need to find the density of carbon tetrachloride, so you would need the mass of it. And that's what Filano just told me to do. So now what do I do? Okay, so I can put it here. Okay. Okay, is that what you guys got? I didn't use my calculator. I'm trusting you guys. I'm asking you what you got on your paper. You did it. 1.59 grams per milliliters. All right, 357. 1.59. Yep, that's what I got when I did it on my calculator. Yes. Yes. So did everyone get this one? Because this is the kind of stuff I'm going to put on your quiz, not the easy. I'm going to put stuff like this. So make sure you understand what happened. All right. Sure. Oh, sorry. Go ahead. Who? I put it back. Go ahead. Perfecto. Number 6, calculate the density of sulfuric acid if 35.4 mLs of acid, of the acid has a mass of 65.14 grams. Rocco, take it away.
We already have volume. So volume is 35.4 milliliters, and the mass is 65.14 grams. Then you have to figure out what you have to do. And mass density equals mass divided by volume.
Okay.
So P equals 65.14 grams divided by 35.4 milliliters. With mass.
Okay, give me 3 figures. 1.8 what?
1.84.
1.84 grams per milliliters. Do we all agree? Yes. Sure. All right. Number 7, find the mass of 250 mLs of benzene. The density of benzene is 0.8765 grams per milliliter. All right. Jonah, take it away.
We already know it's benzene, so like E equals 0.8765.
What are the units? Okay. All right.
And then, so try to find mass. So mass is unknown. Then the volume is 250 milliliters. So now the way I just did it, E equals so basically what I did is I multiplied the density of the volume.
Okay, so just a second. I'm going to plug things in to the formula that I have, and then you're going to tell me what to do. 6.5 grams per milliliter. The mass, I don't know. My volume. So you said that you did the density times what? Okay, so you did 0.8765 grams per milliliter times 250 milliliters is equal to the mass, which is cross multiplication, right? You did 250 times this and then 1 times m, same thing, right? Okay, cool. And what cancels out? The milliliters cancel out, and what are you left with? Grams, right? Which makes sense because we're solving for mass. So what did you get when you did that on your calculator?
I got 219. I rounded it to 219.12. This is 1.5. Yeah, 1.5. I just.
Okay, so you guys want to stick with the 125?
I did 1.4. I did one.
And what are my units? And that gives me a math. Is this the right? Let's do it on a calculator. 0.8765 times 250. Yep. Great stuff. Good job. Yes. Sure, so it would be 2.1912 because you have an even number and a 5 after. Cool. All right, who's doing 8 for me? Someone I have not heard from. Luca Hartley. Pardon me? It's not a question. Pardon me? Mm-hmm. All right, Luca, let's rock and roll. I'm gonna read it and then you're gonna tell me what to do. Shh. All right, guys, quiet down. A block of lead has dimensions of 4.50 centimeters by 5.20 centimeters by 6 centimeters. The block has a mass of 1,587 grams. From this information, calculate the density of lead. Okay, so Luca, first tell me what I have. What have they given me? Okay, so grams is what? A mass? Cool. So my mass is this. Okay, so I don't have the volume yet, but I have some measurements that I can use, right? So I'm going to say length is equal to, I'm going to say width is equal to 5.20 centimeters. And I'm going to say height is equal to 6.00 centimeters. What can I do with that? So, oh, wait, before we do that, what are we looking for? What are they asking me for? Density, okay, cool. And now what's up over here? Okay, so I'm gonna do
1 million.
times 5.2 centimeters times 6.00. So what's the answer? 140.4 centimeters cubed. Did we all have that? Okay, so what formula am I using? I have mass, I have volume. Okay, cool.
Equals.
It's okay, he's doing it. Okay, 11.3 what?
11.303.
Okay, so I'm just gonna put that grams per cent. Is that what you guys got? 11.30 grams per centimeters
Lead
cubed.
has a high density.
Pretty dense. It's lead.
That's the density of all lead, right?
Yeah. All right, 9. 28.5 grams of iron is added to a graduated cylinder containing 45.5 milliliters of water. The water level then rises to the 49.10 ml mark. From this information, calculate the density of iron. Now this one has what method is in here? What has happened to the water? What's that word?
It has increased.
There's a word for that. Displacement, right? So we have a solid. We are using water displacement to figure out what? The volume, okay? So what do I have? What is this 28.5?
Mass.
What am I trying to calculate?
Density, but you have to find volume too.
So I need the volume. How do I figure that out? So the volume is the total water displacement. How do I figure that out? Yes. Okay, so I'll take away 45.50 milliliters from the 49.10, right? Because it starts there and then it displaces. It displaces the total amount of volume of the solid that I put inside. So what is the volume? 3.6. Does everyone have that?
Yeah, everybody has that.
I have 0.1.
I have 3.60.
Okay, awesome. So the density is equal to what?
It equals to.
Wait, hold on. Miguel's talking. Okay, and what's the volume? So what's my density? Okay, 7.92 grams per milliliters. Do we all have that? Okay. Do we have the ballpark figure, right? So density is a characteristic property. No matter what the situation, as long as you have the same substance, the density should always be the same. All right, so the last one quickly.
I'll finish it off with a double. Mine has longer spacing.
But you have the first couple of numbers the same, right?
I have 7.92
Okay, okay. Okay, what volume of silver metal will have a mass of exactly 2,500 grams? The density is 10.5 grams per centimeters cubed. That should be up there. So what am I looking for? Go ahead, Lucas.
Okay, so your volume.
That's what I'm looking for?
Your volume, right?
Okay.
So you have yellow question mark. Density is 10.5. And the mass.
10.5 what?
Grams.
10.5 what?
Oh, the density. Centimeters cubed. And your mass is 2,500 grams. Okay, so now V. So I'm just V equals that. And then V.
Hold on a second. I'm just going to plug that stuff in. My mass is, okay. And
Cross multiply or you can switch this and whatever. So you have 10.5 times V.
is it like that? What's the formula in the end?
The formula and V equals 200 grams over 10.5.
2,000.
Look at the wrong one, sorry. Look at the wrong one. No, wait. Yes, that's V equals 250 grams over 10.5 grams.
Okay, so what's my volume? What's the volume? 23 point what? And just a second, sweetheart. Do we all have that?
No, I saw 230.